Okay, this is just a quick demo of the Service Telemetry framework. This is STF 1.5 running on top of OCP 4.10. Quick overview, look at the architecture. So Service Telemetry framework operates with ROS-P 13, 16.2, and the 17 series. The container images basically run on top of OpenStack. They collect data using collectd for infrastructure telemetry and Ceilometer agents for the platform telemetry. Those events and metrics are passed to the AMQ interconnect, which is an AMQP1 message bus that provides the data transport from the OpenStack platform to another AMQ interconnect operator driven router. That router basically receives the data and exposes it to the data storage domain via the smart gateways. Smart gateways are effectively middleware translators that either provide a scrape endpoint for metrics so that Prometheus can scrape it locally, or the events can be written into an Elasticsearch data store. We can create a service telemetry object using our console. We've already got the available operators installed. That can all be done from the documentation. So we prepare our OpenShift environment and we install everything, and that can be done here. So once we have our operators installed, we can create a service telemetry object. We can follow through on most of the defaults. We're going to enable some extra items here. We're going to make use of persistent storage. In this case, we are going to enable the Elasticsearch storage. Loki is not really a supported backend, so we're going to ignore that for now. Prometheus, we're going to enable. We're going to just make use of our default clouds. So this is how we define our smart gateways. And this is the subscription address from the message bus. And we do that for our events, for notifications, events, collectd, and other endpoints. We're going to also enable graphing, which is provided via Grafana. Make sure that we can access it through our route. We are not going to use high availability right now. And that's pretty much it. So we'll create our service telemetry object. That will then be created by the operator. Service telemetry operator will make other requests and create other objects, and then the other various operators we have installed will act on them, and we will end up with a deployment. So we can follow everything happening here. And we make use of Ansible. This will create all of our objects against our OpenShift environment. And we can just watch all this stand up. It'll take just a few minutes. So our operator has reconciled. We can see all of our pods running here. Everything's active. Go to routes. Load Grafana for our dashboards. The dashboards are loaded in via objects. I've already created them. OC get Grafana dashboards. We have events. It's not a very interesting dashboard. Our overall cloud view. Let's look at the last 5 minutes since we've just instantiated this environment. We don't have very much information yet, but we can see that everything is already active and we're receiving from my staged OpenStack environment. So Some other interesting dashboards. We can drill down to the infrastructure level, so we can look at specific nodes within our cloud environment. So this is a Ceph node, we have compute nodes and controller nodes. We also have the memcached view, which is just showing memcache information from the cloud. Just another example dashboard you can use of creating service-based dashboards. Drill down to the virtual machine view. For this project, it's the UUID. These are 2 virtual machines I have running inside of that project, and we can just see the information about the virtual machines themselves. Go ahead and actually stress test one of these virtual machines. So we can run that stress test, and then we'll set our refresh rate fairly high. We can already see that we started receiving data from that stress test. Our polling rate is about 10 seconds scrape interval, and the polling rate on the OpenStack environment is 5-second resolution. For collect D, in large environments, you probably want to tune that down a little bit. 5 seconds is probably a little aggressive. And then Salometer by default is 30 seconds, which is polling the services and polling Nova for some additional virtual machine information. That's pretty much it. We can also perform a few other fun items here. Operational features. So we got our dashboards from the operational feature creation here. We just enter some data into the console for importing the dashboards. We can create alerts for Alert Manager. We have some example rules here. Load that in and go to our Prometheus route. And that will take a little bit for that to load in. So we have our rules, and that can be extended. And we've got traps. Just create a little collector here. And I previously sent an alarm, and that alarm was sent via the Prometheus webhook SNMP middleware that we have, and that sent an SNMP trap to this SNMP trap receiver. And this is just an example of some output of the trap.